All right, we're coming at you right now from the labs here at HackerBoxes. HackerBoxes is the monthly subscription box for DIY electronics and computer technology. Check us out at HackerBoxes.com. All right, so we're going to be working with this surface mount soldering kit that was included in HackerBox 0019. You can find some more information on this for the instructions for that box. If you go to hackerboxes.com and follow through to the Hacker School, you can find the instructions for box 0019 where you'll see some schematics and a bill of materials and some other information there. And also see what else was in the box and find out how to get a box like this for yourself in your mailbox every month by becoming a member of the HackerBox subscription box. All right, so as you can see, this kit has a PCB. It's pretty small, and a whole variety of surface mount parts that we can practice soldering. And so the point of this sort of kit is to, get to practice soldering. It also has a function that we'll see in the end once we get it hooked up to a battery. So let's put the parts away here so we can get started with one part at a time. We're going to start with the integrated circuits since they're probably the trickiest and also in the middle. You'll see that we'll be following the rule as you typically do when soldering circuit boards to work with the smallest components first, but we'll also be working from the middle out to some extent just to avoid having to solder over previous work. All right, so we're going to take this 4017. This is a 16-pin SOT device, and it's a decade counter, and it's a pretty commonly used in conjunction with a 555 to make what we call an LED chaser or an LED sequencer. It's a pretty common circuit, but this is a little different as it's a surface mount version. So with these type of surface mount integrated circuits, the trick is just to get it lined up over its footprint close enough so that you can tack down one or two corners. The first one can be a little forgiving because you can move it afterwards by just heating it up a bit, but just get it kind of lined up and melt the solder on there and get the solder to flow. And when you're tacking it down, if you don't have a great solder connection, that's okay. We can go back to that later after we have the whole chip connected. So with two pins attaching it down to the board, it's pretty much held onto the board now with solder. And we can go through and just flow solder onto each pad and each lead. And if you had a little flux pen, or especially the kind with a tiny syringe tip, that can be helpful with this. We're not using any flux here. Should be all right. And we're also just using a regular illuminated magnifier, like a lighted magnifier, over the board. So we're not even using a microscope. So we just wanted to show that you can do pretty tight surface mount soldering almost by eye, but using a magnifier helps, and that you don't really need any special tools. This is a pretty nice but quite inexpensive soldering iron. You can get these from Amazon for $30 at the most, and you get even a slightly nicer version for $50 or $60, and just use a very fine tip cone shaped soldering tip. Some people like a little chisel tip. That works well too. And you want some pretty skinny solder so you can focus the solder right on the lead and pad for each one of these surface mount leads. And we just work our way across, flowing the solder onto each one. And like I said, if the first one you solder down, and we'll see this more with the chip type components here in a bit, but the first one you solder down might be, like a slightly cold solder joint just because you're just trying to get it tacked while it's moving. That's okay. Just, hit it again at the end and make sure you get the solder to flow. And I apologize for the wobbling of the camera here. The camera is actually attached to the display, and so I'm trying to keep my hands very flat to the counter, but every once in a while I bump the magnifier a bit. And with the camera on the magnifier, every whole thing can shake a little bit. All right, so that integrated circuit is totally held down now. You know, since one whole side is soldered down, so we just repeat the whole process on the other side. And you just got to take your time and just do each one. And the thing that can be tricky with these is sometimes you might get a solder bridge between the leads. So in which case, it's good to have a suction or a solder wick to take the solder out. But if you're just really careful, don't get any solder in between the leads to begin with. That's the best route. All right, so that's our SO16 packaged 4017 decade counter down. So now we're going to move on to the 555 timer. For those of you that have been with HackerBoxes for a while, you may recall we did a whole box centered around the 555 chip, and we did the Evil Mad Scientist 555 replica. We made a giant 555 chip. It was pretty cool. I think it was 26 transistors that make up the 555 timer. All right, so with this little 8-pin SO8 package, we're going to basically do the same thing we did with its with the bigger one. It can be a little trickier to line up the smaller chip just because it wants to move around a little more, but other than that, it's exactly the same. I mean, in some regards, it's harder, but then on the other hand, you have less pins to solder. So, just jumping around here. So you see that we have some tweezers on here. There's a lot of different ways to do this. I'll show some different techniques here in a minute. One of my favorites, especially for the smaller parts, is just to hold down the part with the back of a wooden swab. It's how I was actually originally taught to do surface mount soldering, and it seems to be a really good technique, so we'll give that a shot here in a minute. Kind of need 3 hands to do this. So. Alright, we'll just go through and flow solder on each lead just as we did with the last IC. I scratched the top of the case there a little bit. It's just plastic. Doesn't affect the circuit in any way. I did want to comment. We have the if you have an adjustable soldering iron, you want it just over, just hot enough to flow solder, and not much hotter than that, because we're touching the soldering iron right to the integrated circuit. So we want to just be careful about not putting too much heat in there, especially with the integrated circuits and the LEDs. So now we're moving on to the Npn transistors. These are in a little tiny SOT23 package. They're also along with the integrated circuits, these are probably the trickier things to solder. So these are actually just drive transistors that drive the 4 blue LEDs at the each corner of the board. So. And it's easy to see how these orient, because there's 2 pins on one side and 1 on the other, so that makes it a little bit foolproof as far as the orientation goes. I'm a little solder party right now. Let's clean that up a bit. So I like to make sure the tip is really well tinned, so and then also get a little bit of extra solder on there to help tack the first lead down. And here I'm just going to use the back of the wooden swab this time and push down on the component with the back of the swab. I just push it right down. I say I'm getting it like it's a tree stump. I just stump it down on there, and we'll go back and make sure that the solder's flowed on that first lead that we tacked. All right, fair enough. Looks good. All right, and like I said, we have 4 of these transistors, and these are the NPN drive transistors. They're actually driven by the carry output of the counter, so that whenever we switch the highest bit or the highest output of the counter, it flips the state of the four blue LEDs. This board has 4 blue LEDs on the outside, and it has 10 red LEDs that go around in a circle, and then there's another red LED right in the middle that serves as sort of a heartbeat that actually tied directly to the clock. So it's a pretty interesting visual effect. All right, so we're gonna go to the center now and do the heartbeat LED that's right in the middle. It's one of the 11 red LEDs, and that's going on the position D1. And you see, we look at the bottom of the LED package, especially for the red ones. With the blue ones, you can see the polarization actually through the lens a lot better, but on the red ones, it doesn't show very well through the lens, so we look at the bottom of the LED to make sure we're orienting the LED correctly. There's a little T-shaped pointer that points towards the cathode, meaning the bar of the T is towards the anode. And the markings on the silk screen have a thickened line on one side of the LED. You can see here it's on the right next to the marking D1. It's a little thicker. It's the side of the LED facing away from the two chips. And so that's the cathode, the thickened line in the outline. So we make sure that the cathode marking on the bottom of the LED is pointing towards that side of the LED. And then with these, it's go ahead and just tack one side down and then flow solder onto the other side, and then flow it. Make sure the original side that was tacked is flowed, since it might have moved while you were doing it. So that's how you do these little components are in what's called an 0805 package, which is actually, as far as surface mount goes, they're pretty easy to solder. There's actually several steps smaller than the 0805. So 0603 and the 0402, even smaller than that. So we're not working with anything ridiculously small here, but it's still not the easiest thing in the world. So it's good practice. So now we're going to do these are the signal diodes. They're 4148 diodes, which are pretty common, and they're in these little barrel packages. It's called an LL34 package. And with these, we have to, you'll see there's a black line on the anode side. And I'm sorry, on the cathode side. So we're going to orient these 4 signal diodes, and these are the D12 through D15. We're going to orient them with that black line facing away from the integrated circuits. And if you see really closely on the silk screen, these 4 diodes in particular have a little diode symbol that shows you, there's a triangle and then a straight line, and the straight line is the cathode, which is also the side that has the black marking on the device itself. So it's oriented in that direction. So if you were to face the circuit board so that most of the silk screens, the ones that aren't in the circle, are oriented right side up, then the black line, or the cathode of these signal diodes goes upwards towards the top of the board. And these are a little trickier because they roll, so they're a little harder than the LED was, or than the other rectangular components could be, because they're a barrel shape. But if you hold them in some tweezers, they're big enough you could probably almost hold them with your finger, but because they're round, you can't really stump them with the swab. You also can't just leave them there on their own. So it's a little trickier, but they're not too small. So this is really good practice for doing surface mount. Oh, so sometimes it jumps off. And just take your time and loosen it up and reattach it. Surface mount soldering takes a lot of patience, and so what happens sometimes is if you have one side soldered and then you go and do the next side before the first side cools, it can move when you put the soldering iron near it. It might jump onto the soldering iron. It might push out of the way. So sometimes it pays to just go a little bit slowly. I make that error a lot. I start moving a little too quickly, and then I'm jumping from one pad to another before the first pad had time to cool and solidify. I get the third one of these 4148 diodes on here. So it's good to look at the schematic, almost memorize the schematic before you start building these. And certainly the bill of materials. I like to maybe even have the BOM sitting there so I know what parts are what. But the understanding what the circuit does, helps you kind of double check, do a sanity check on what parts are going where. So these all these little components that are going in the middle, the center of the ring are a little more closely associated with the two integrated circuits. So there's some, there's the resistors that set the oscillating frequency of the 555 oscillator circuit, and there are some, these diodes are part of the drive circuit for the four blue LEDs. Alright, so here we have the last signal diode. Sorry about the camera there. Alright, so we have the center, the heartbeat LED, the red LED, and then the four signal diodes around it are all attached. Now we're going to do the components in the next row over. The ones in the center are the two ceramic capacitors, C27 and C28. So, like I said, we're working from the middle out to maximize our Weissman score. So Ehrlich Bachman likes to make sure we solder from the middle out. No, joking aside, we with these, it's good to go from the work from the center so that we can, not be having to solder over other components. Not that it's that difficult, but so we're getting these little tiny 0805 capacitors. So these have no marking, but they're kind of a beige, light brown beige color. These are they're 0.1 microfarad capacitors. They're pretty common values. So we have two of these right in the center here. They're the only capacitors on this whole board. I think after this video, you might never say that this is fun as watching paint dry. You might say this is as fun as watching someone solder surface mount components for an hour. It's about the same as paint drying. Alright, so for this one we'll get it lined up on here. Maybe let's try a different technique. Go back to stump it. So the problem is when you have the soldering iron in one hand and the stump in another hand, you can't really hold the solder up. So you're going to get a little solder on the tip first, which, as you probably know, is not good soldering technique to deliver solder from the tip of the soldering iron. I think a small alien just ran across my field of view. Okay. They're very small. I think they trying to repopulate the earth with their six-legged friends. All right. Solder float on both sides of that capacitor, and we're all set. So these two little chip capacitors, one of them is part of the frequency setting circuit for the 555. So that's an important value of that capacitor, along with the value of two resistors, helps set the frequency of the 555 oscillator, which is about 3.5 hertz. So the heartbeat beats pretty quickly, maybe a few times a second. All right, now the rest of the components on this row of 0805 parts inside the ring here are all resistors, but they're all different values. So you want to make sure we're checking. We have a 2 mega ohm resistor in there, and then there's there are a few 10k ohm resistors in the, and all the other resistors on the board are 470 ohm resistors. But those are all of those are used as LED current limiters, so they could really be anything up to, from about the value they are up to about 2k. So if you happen to lose one of those and need to use a different value, that would probably be all right. Alright, so as we do these, it's pretty straightforward. We just do what we did with those two capacitors. The resistors are exactly the same way. You just get it to stick on one side, then flow solder on the other side, and then if needed, go back to the first side and make sure you get a good flow so that you have a nice shiny surface on the solder. If you have something that looks like crumpled aluminum foil, or is dull, it's probably a sign that you didn't get a good solder flow, and it's good to go back and check it out. So we just go across and do all of these. Let's see here. This R61, 62, 63, 64 are all, those are all the 10k resistors that they're part of the drive circuit for the 4 blue LEDs that are, so basically these go from the counter, the signal from the counter goes through each of those signal diodes we already soldered, and then through these four, each one goes through each of these 4 resistors, and then that's what drives the Npn transistors that we earlier did. And that's what those are part of the stack that turns the blue LEDs on and off, so that you can get a lot of power into those blue LEDs. And like I said before, these are being driven by the carry output of the counter. So if everything works when we power it up, we'll see what see what that means. The blue LEDs are driven by the carry. All right, and then one more. 10k. Get in there. So now we'll go ahead and do the 3 resistors on the other side of this row. These 3 resistors are all 3 different values. So a lot of times people like to open up a strip of the resistors if there's several different values, and do all of one value at once and then move on to all of the second value. But here, since they're kind of interleaved, we're just doing them from the center out. So you just have to kind of keep track, and it's easy enough here because the big long strip of resistors, the one where we have 15 of them, those are the 470 ohm. The shorter strip where we have 5 resistors, those are 10k ohm, and the 2 mega ohm resistor is all by itself. It's just a single resistor, so it's quite easy to keep them straight without even having to put them into separate bins or anything. So we'll go ahead and do these 3 resistors, And then around the ring we have 10 red LEDs, which are just like the one we did the heartbeat in the center. They're from that same strip. And then 10 current limiting resistors. Those are those are the 470 ohm resistors. So just do these 3 resistors and then do the 10 resistors and diodes around the ring here. All right, now we have just this last red LED to complete the ring. I'll go ahead and check the bottom for the cathode pointer and make sure we have the right orientation, and go ahead and tack one side. And so we thought, can't move it while the soldering iron's still on it. And then we'll make sure we have a good flow on both sides. All right, that finishes up our whole ring. We have our 10 LEDs and 10 current limiting resistors. So those are all set. And now we have the 4 blue LEDs, and there's 4 resistors, also 470 ohm, or 470 ohm resistors in the corners. So we'll go ahead and finish those the 4 corner resistors and the 4 blue LEDs. And that's all the surface mount components. The only thing we have left now is we're going to put these single row header pins. There's 5 pins. We're going to need to cut that down into a 2 and a 3. And then we can put those in the ports allowed. So this 2-pin header basically connects the 2 leads that are across the 2 mega ohm resistors. So if you short this while the other header is shorted, you can basically light up all the LEDs at once. So that's one thing you can do with this. Also, if you wanted to remove the 2 mega ohm resistor, you could put a large value potentiometer on there, and you could have a speed control. It might be kind of an interesting effect. And on this 3-pin header, when you short out the top 2 pins, that actually, and there's a jumper, they give you a jumper to do that within the kit. That allows you to connect the output of the 555 oscillator with the input to the decade counter. So that that jumper actually lets you connect and disconnect the 555 timer. So when you disconnect it, the counting stops, and the LED moving around the ring, or the light effect moving around the ring will cease moving, and it'll just stay in one position. And then when you short it back down, the heartbeat LED will start going again, and it will the light effect around the ring will move around. So let's go ahead and test this out. So that's it with the counter just in a single position. And then you can see if I'm going to try shorting the bottom half of this thing, which doesn't really do anything. It just grounds the output of the timer, so that's not incredibly useful. But if we short the top 2 out, we're connecting the timer to the counter, which will give us our pulsing effect with a heartbeat, and then the LED moving around the ring. So we're going to go ahead and solder down the battery leads like this, and since it's just 9 volts DC, we're going to just solder it without pulling the battery off. Don't normally recommend that, but so tin the leads from the battery clip. Very good connection on the board, and then we'll also tin the pads on the board that they connect to. And just melt them into place. With the plus side's plus and the minus side's minus. Or the plus side's red and the minus side is black. There we go. And so you can see the LED in the middle is connected to the clock output from the 555 timer. So it is sort of like the heartbeat of the whole system. And you can see for each pulse, the counter moves to the next bit position, causing that LED effect to go around the ring. And then every time you trigger the carry, we'll see how that happens. When we trigger the carry, which happens when the rotating LED effect is at either of the side positions, that toggles the state of the 4 blue LEDs because they're connected to the carry output. So, all right, well that's it. Thanks for playing along, and be sure to join us at HackerBoxes.com and on social media. Take care.